Hello everyone, and welcome to part 2 of this OpenLabeling tool. So in this I'll be showing you how to label images or videos using a pre-trained model's frozen inference graph in main AutoPy script. So in this script, we can use a pre-trained model's frozen inference graph to train images, to label images. So suppose we have 10,000 images and we label 2,000 of those. So we can use these 2,000 images to train a deep learning model and then create an inference graph for that. Now to label the rest of the 8,000 images, we can use this frozen inference graph in this script over here. And what this will do is basically it will run object detection in all these 8,000 images using this frozen inference graph, and then automatically label all those objects in all those images. So let's begin. So for this we'll need TensorFlow. I already have TensorFlow installed on my system. Since I have CUDA 11 and CUDNN 8.0 for CUDA 11, so I have TensorFlow 2.4.1, which is the latest version. Let's open the command prompt over here. You can install TensorFlow using this command. So I already have TensorFlow 2.4.1. You can check. I have TensorFlow 2.4.1 installed. So this main_auto.py script that is over here on this OpenLabeling's GitHub, this works for only TensorFlow 1. It doesn't work for TensorFlow 2 and above. So we will have to make a few changes. So if you go over to my article, you can read the changes that we need to make. So open the main_auto.py script and make these changes. If you're on Windows, so change this in line 29 to this. Line 29 over here, change this, change line 30 from object detection, remove object detection, line 47 from the graph path mentioned here to the path of your frozen inference graph. I'll simply put the inference graph alongside the main_auto.py script. I'll just put it over here. So to give its path, I'll just write frozen_inference_graph.pb, and that's it. And for the next change, so if you're labeling one of the object classes in the pre-trained model, such as Coco, which has 80 classes, you can simply download the pre-trained model and put it inside a folder named models inside the object detection folder, as mentioned on this page. How to use the deep learning feature, I have given the link over here. So they should have a folder named models. Inside that, a pre-trained model over here, and then inside that we have a frozen inference graph. But right now I'm training my own custom object mask, so for that I'll be using my own frozen inference graph. I have already copied that. So for the next change, go to line 327 and change this new path, replace 1 to this. Okay, so this is line 327. Change this to this. Because what the old command did was it created an output directory and it saved these XML and text files out over here. I did not want that. I want to be able to edit, view and edit my auto labeled images later. So for that I'll be giving this path. Let's delete this output folder. Again, go back to this. So make the above change so that the label text and XML files are written inside the Euro.NET and Pascal VOC folders. So if you want to view and edit your new auto label dataset, we can use it, do it just by running the main.py script. Okay, so we are done with editing our main_auto.py script. So the next thing we have to do is edit tf_object_detection.py script, which only works for TensorFlow 1. So I've mentioned it in my article as well. So make these changes only for TensorFlow 2. So if you have TensorFlow 2.2 or above, so you can make these changes. If you have TensorFlow 1, then the TF object detection module, which is given here, which I mentioned earlier as well, over here. The TF object detection module given on the official OpenLabeling GitHub page will work for TensorFlow 1. So you can skip this, you can skip all these changes if you have TensorFlow 1. For TensorFlow 2, just follow along and make the following changes. So again, go to the object detection folder, open this. Now we've already made changes in this, just save it, close this, and now over here we have to make these changes so that it is compatible with TensorFlow 2 and above. Line 9, change TF session to tfcompat.v1 session. Line 16, change TF graph def to this. Line 18, change G5, make these changes. Line 25, 33 and 34, make these changes. Sorry, this is one single change. 25, 33 and 34, and that is it. Save it. Now this will work with TensorFlow 2 and above. Okay, for the next step, we have to edit the class list text file. So it should be in the same order that we used as in the label map.pbtxt file. which we use while training a deep learning model. So just one thing to remember, the label map ID index 0 is reserved for the background label. So this is how I initially used my class list.txt file to label images. Let me show you what I actually did. I had this data set, two data sets actually that I used, these two. So I have these images over here in the input folder, and I manually labeled all these images. There are around, yes, there are 1370 images in this. So I used this class list file. So let me show you. Okay, so as you can see, this is the dataset that I used. I manually labeled all these images. So just like so. I'll be uploading this labeled dataset on my Google Drive. I'll be sharing the link with you. Okay, so the next thing that I did is that I used these labels and these images to train a deep learning model. And that model, while training, this is the label map.pbtxt file that I was talking about. So when this is generated with starting from ID number 1, as I mentioned earlier, and also you can read that on my article, the label map ID index 0 is reserved for the background label. So that is why I wrote this as unknown. You don't have to use this. Then while training, after training the object detection model, I created a frozen inference graph. As you can see, I just did this for test purposes. So the loss did not even go below 1. So I ran this for a few hours, and then I converted it into a frozen inference graph. I'll be uploading a tutorial on this object detection using deep learning models soon. So make sure you subscribe to my channel so that you get a notification for that when I release this video. So I'll be showing you how to train an object detection model for a custom dataset using deep learning models. So okay, check that out. Okay, so now we have this frozen inference graph. So basically what I did was I used around 1370 images, and I used those to create a frozen inference graph. And now I can use this inference graph to label other images that have not been labeled, say like 10,000 or 20,000 images. So as earlier we have downloaded a new data set, so we'll be auto labeling that now. Okay, now for the next step, edit the config.ini file. You can change the object score threshold to whatever the minimum accuracy that we require for our object detection. Right now it's 0.65. You can set it to 0.3. We already have object IDs. You can set to 1, 2. And save it. You can also set your CUDA visible devices number to 0 if you have CUDA and CUDNN installed and configured on your system with a CUDA capable GPU device. I have an NVIDIA GeForce 1070, so I also have CUDA and CUDNN installed and configured on my system. So I'll be using my GPU. Obviously this will speed up your labeling process But if you don't have CUDA or CUDNN, you can still use this main underscore auto.py script. It will be a little slower, but it will still work, so that's not a problem. Now final step, run the main underscore auto.py script. For images, we'll use this command, do the same process. We have copied these two images, your entire image dataset. Just copy it inside the input folder and run this command. You don't have to write mention your input directory and output directory every time, or even the thickness. It takes the default values for input directory, which is input folder name input, and creates an output folder named output. And the default for the thickness of the bounding box is 2. You can change this to whatever you want. Okay, let's run this. I'll give it 4. What I'll do, instead of using just 2 images, I'll download an entire new image dataset for demonstration purposes. Delete the output folder. Also delete this. Now keep in mind the frozen inference graph that I have over here. I used around 1,000 images just to quickly train the deep learning model. So I used SSD MobileNet model to train this. So if you go at the bottom, you will find more dataset sources for mask as well. I have used these two to train this frozen inference graph. So let's say we download this from Kaggle. You can find a lot of datasets on this website. So let's go ahead and download this. Make sure to read about its license and usability, everything. Okay, so the download is complete. Let's go over and unzip it. Okay, so this already has annotations, the Pascal VOC annotations, the XML files. It does not have the YOLO darknet text files, but right now we just need the images. You can delete the annotations. So let's just copy all these images to, again, the input folder. Okay, so we have all these files over here. If you want to change their name, just make sure you do this prior to running the main.py or the main underscore auto.py scripts, because the XML files, the Pascal VOC format label files, they contain the name of this input image file. So you can change this before running the script. I'll just name it mask. This will name the rest with numbers. Okay, so now let's run the same command. As you can see, it has successfully opened all the libraries that I have for CUDA and CUDNN, but it gives error. I'm gonna close this. It gives me error over here, CUDA error, no CUDA capable device is detected. That is because in the config.ini file I did not give any device number to this. The GPU for my system, physical GPUs, the device number is 0. Just write 0, save it, and now we'll see that it will be able to detect my GPU. Yep, as you can see, this has detected my GeForce GTX 1070 with compute capability 6.1, and all the libraries, they are working. And this will look like this if your GPU is working properly for CUDA and CUDNN. Okay, so as you can see, it is performing object detection on all these images and auto labeling the masks in all these images. Now, if you have too many images, suppose like you have 20,000 images, obviously the GPU will work faster. So if you can configure CUDA and CUDNN for your GPU, try to do that. But this will work fine without your GPU as well. So I'll just pause this and come back later. Okay, so it took less than 4 minutes to auto label around 850 images. Okay, now we can view these images using Python main.py command. You can use thickness is 2. It gives this warning because I'm using PNG images. If you have JPG images, you will not see this warning. You can ignore this for now. Okay, as you can see, there are many images where the objects have not been labeled correctly. You can manually label all these images. Like so. But most of the images will have been labeled. So you have to do the manual work as well. This just saves a lot of time and effort on your part. As you can see, most of the close-up images will have been labeled, but most of these are long shot images. The frozen graph that I had was from mostly images from the 2 datasets that I used to train, which mostly had only close-up images like this, and only very few long shot images. So the better the quality and the content of the dataset, the better will be the outcome. So always try to find a good quality dataset. So okay, let's move on to the next step. Okay, and also you can do one more thing. You can copy the newly labeled dataset and put it alongside the old dataset which we used to train our frozen inference graph. Let's put the images alongside these images and copy the output files as well. Okay, so now that's done. Now what we can do is when you run the main script from the folder containing all the images, including the old dataset and new dataset, you can view and edit all the images from over there now. Okay, so as you can see, now this will have both the datasets, the old one and the new one over here. Now the old dataset had 1370 images, the next dataset had around 850. So as you can see, I have more than 2200 images over here, and all of them are labeled, so you can view and edit all these images here as well. Just make sure to keep them in separate folders when you are running the main_auto.py script, because this script, if you run this again on this dataset, it will label these images again, which means it will create another boundary like so. The more times you run this, it will create bounding box each time. So keep the new datasets that you want to label in a different folder than this. Okay, so let's move on to the next step. So this was for images. Similarly, for videos, we have to follow the same process. Just copy the video into the input folder. Let's delete the output. Let's delete all these input images. Let's copy the video. Okay, copy and paste, and then use the same command over here as well. Just run this. It will load all the libraries, and then just as we did with the main.py script for videos, this will convert the video into individual frames first. So we'll have 605 frame images, and then it will perform object detection and auto labeling on those frames after that. Okay, so as you can see, it is running object detection on all the images that were created, all the individual frames that were created. It is running object detection and auto labeling all the images itself using the frozen inference graph. So it's as simple as that. So if I had like 20,000 images or like a bunch of videos, I could use a frozen inference graph that I had trained using only 2000 images, and I could label the rest of the 20,000 images using that. So this main_auto.py script makes it so much easier. Okay, so it has finished labeling, auto labeling all the images. So you can view and edit the new auto label dataset using the main.py script. Okay, Let's give the bounding box a thickness of 4. Okay, so as you can see, we can individually check all these images to look for an image labeled or unlabeled frame. So it took less than 3 minutes to auto label all these 605 images using the frozen inference graph of my pre-trained custom model for mask detection. So okay, that's how we use main_auto.py script to auto label a video. So this was section C of my article. Now the next section, that is section D. If you go over to my article, you can read about other labeling tools. One of the most popular labeling tool is label image, and the GUI for it looks like as shown below. And I've given a few more links for various other labeling tools down below. You can visit these links and read about them. I've also given all the links for my dataset sources, my mask dataset sources down below, and also given the links to my GitHub for my custom trained frozen inference graph for mask detection. So you can use this for test purposes, and you can download my edited main_auto.py and TF object detection for TensorFlow 2 from here. I have uploaded it on my GitHub. I have forked the OpenLabeling tool, and I have put both these updated files in this update folder. You can use these if you have TensorFlow 1, so you can use the one that is given in the original GitHub page for this. But if you want for TensorFlow 2, you can download these two files and put them in the respective folders. So okay, if you enjoyed this video, please click on the like button and make sure to subscribe to my channel. And okay, I'll see you in the next one.